Hello and welcome to our mini test solving, and let's get right ahead into it. First one wanted us to sketch the graph of the function and answer some questions. So the function given is x to the power of 3. So we will mark the common points, which are -1, -1, 0, 0, and 1, 1, which are the common points for odd powers where k is +1. Then we connect them in a smooth curve, rising up. As we get the greater x, we also get a much greater y. So we would get something like this. This is the exact graph, but for sketching, it is important that you show that this can extend to any x. You go through these 3 points and you make a curve. Now, to answer the questions, we need to know if it's symmetric and what is the element of the symmetry, which basically asks if it's mirrored over the y-axis, x-axis, or the origin point. And here we see that, yes, it is symmetric, and the origin point is the mirror point. Yes, over 0, 0. Next up, we determine the domain and codomain of the function. We can see that we can insert any x and we can get any real number as y, meaning that the real numbers are both the codomain and the codomain of the function. For some reason, the r's aren't the right ones, but okay. We know what I mean. Next up, we find if it's injective or not. We can do that with the horizontal line test, which I have moved. If we move from down to up, we see there's always one intersection. Yes, it is injective. And to see if it's surjective, we already have the codomain, which is all in numbers. So yes, it's both injective and surjective, so it's bijective. For our second question, we had to determine which of the 3 functions best fits the curve of the graph. So let's look at the common points. I forgot to mark them on the graph, I do apologize, so I just drew them over with a circle. We see we have -1, 1, 0, 0, and 1, 1. The triangle shape is common for even exponents, where k is +1, so the second option is automatically out. Now, if we could watch how smooth versus the rigid the curve is, it's easier to find some other points like 0.5x or 2x, or any other that we know the square of. Since x is 2 is shown on the graph, we can see if we have the point 2, 4, as we're testing for x squared. So 2, 4, we go up. Oh, 4 is here? No, we don't. But what can we see? Oh, we see that there's a point 216. Okay, so that is x to the power of 2, meaning our last option was correct. For the question number 3, we had to select or circle all that are the properties of x to the power of 5. That might not have been correct English, but who cares? We're doing math, not English. So I'll go one by one and explain why each is or isn't correct. So the sketch isn't necessary, but I will give the graph here as it can help us better. First, is it symmetric over the y-axis? We know it isn't. We see that it is symmetric over 0, 0, but not over y, so this is wrong. Now for the output. We see that the y values reach into negatives, so output cannot always be positive. As we clearly see, it's negative here. The domain of the function, we can see that we can basically put in any value from real numbers and we still get a result. So this one is correct. 2 more to go, and this one states that there is only 1 0 at x equals 0. And if we look at the graph, we are correct. There is only one intersection with the x-axis. As for the last, since we can get any real number as the y in the function, this function is surjective, giving us the last 3 points correct, the first 2 wrong. And for the last question was to determine which of the 4 functions are the odd ones. I will show the graphs here, especially for the more questionable ones, or one, but I will also explain how you can try and imagine the shape even if you forget. First, we have to know what makes a function odd or even. So putting in a negative x and a positive x, and if we get the same result, that is an even function. So to the power of 2 and to the power of 4 are definitely even. So let's just cancel them out, or gray them out, because negative sign cancels out. Next is x to the power of 3, odd exponent. The opposite signs when we insert opposite numbers, like -2 and 2 give us -8 and 8, meaning it's odd. Great. Now let's check for the last one as well. Absolute value of x. We know that the absolute value makes any negative value a positive, meaning that anytime we insert a negative x, we will get a positive x. We can write this as such. In a way, when x is less than 0, y would be equal to -x. And when x is greater than or equal to 0, y is just x. So if we try to imagine how it would look like, it would appear something like a function of y is x when x is greater than 0, but when it dips below the x-axis, so when it's less than 0, the part that was under it should now be mirrored up, so the function would basically look like y is minus x when it's left of the y-axis, and y is x when it's right of the y-axis. So let's see if we actually did this correctly. We did, so y is minus x on the left side and y is x on the right side. As we can see, this was very accurate. Now to see if it's odd or even, let's put in -2 and +2, which, following the formula for even functions, gives us 4 and 4. So it is an even function despite having an odd exponent, which leaves us with f of the x is x to the power of 3 as the only odd function. Thank you so much for tuning in to solving the mini test. I hope everything went well. If not, you can always comment down below and I'll explain where you went wrong, what could have been done better, or maybe just take feedback so I can improve the future tests. Thank you again, and see you around. Bye!